Hi to everyone. Today we are going to learn about how to find the eigenvalues and eigenvectors of a matrix. Okay, before that we have to know about the characteristic equations. Okay, for 2 cross 2 matrix, the characteristic equation is lambda square minus s1 lambda plus s2 equal to 0. Here s1 is sum of the leading diagonal values. Here S2 means determinant of A. For 3 cross 3 matrix, the characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus S cube, which is equal to 0. Here S1 means sum of the leading diagonal values. And S2 means sum of the minors of leading diagonal values. And S3 means determinant of A. Now we find the eigenvalues and eigenvector of the matrix capital A minus 2, 2, 2, 1. Okay, so the given matrix is the 2 cross 2 matrix. The characteristic equations are lambda square minus s1 lambda plus s2. Here s1 means sum of the leading diagonal value. Here the diagonal values are minus 2 plus 1, that is minus 1. S2 means determinant of A, that is determinant of minus 2, 2, 2, 1. So the determinant value is minus 2, minus 4, that is minus 6. So the equation is lambda square minus of minus s1 means minus 1, so minus of minus 1 lambda plus s2 is minus 6 equal to 0. Here we rewrite this as lambda square plus lambda minus 6, which is equal to 0. Here we have to find the eigenvalues. To find the eigenvalues, to find the root for this equation. Here this is a minus 6. For minus 6, that is 3 2s are minus 6. Here we have plus. So put a plus symbol for the greater number. So plus 3 minus 2. So therefore lambda plus 3 and lambda minus 2 equal to 0. So the eigenvalues are lambda is equal to minus 3, 2. Okay. Okay. Now we have to find the eigenvector. To find the eigenvector, that is A minus lambda into I into x, which is equal to 0. A minus lambda I into x is equal to 0. Here A is minus 2, 2 and 2, 1 minus lambda into the identity matrix is 1 0 0 1 and x1 x2, which is equal to 0. Okay, then this will become minus 2 minus lambda into 2 and 2 1 minus lambda into x1 x2, which is equal to 0. Okay, this is the general equation. Now we have to find the eigenvector for case 1. For case 1 means put lambda is equal to minus 3. Here we find the eigenvalues are minus 3, 2. So first case we put lambda is equal to minus 3. For minus 3 means in this equation minus 2 minus of minus 3, that is minus 2 plus 3, here 2, here 2, 1 minus of minus 3, that is 1 plus 3 into x1 x2 which is equal to 0. This matrix is become 1 2 2 4 into x1 x2 which is equal to 0. This will be x1 plus 2x2 which is equal to 0, and the second equation is 2x1 plus 4x2 equal to 0. The second equation is in the multiple of 2, so we can rewrite this equation as x1 plus 2x2 equal to 0. This is equation number 1, this is equation number 2. Okay, here the above two equations are identical. The above equations are identical. So we put x1 plus 2x2 equal to 0. So x1 is equal to minus 2x2. Then this can be written as x1 x2 and put the coefficient here minus 2 and 1. So the corresponding eigenvectors is, that is capital X1 is minus 2 comma 1 or 2 comma minus 1. In case 2, if lambda is equal to 2, okay, then we substitute in that matrix, that is minus 2 minus 2 2 2 1 minus 2 into x1 x2 which is equal to 0. So this is minus 4 2 2 minus 1, then x1 x2 which is equal to 0. Then this will be minus 4x1 plus 2x2 which is equal to 0. Then 2x1 minus x2 which is equal to 0. Here also the two equations are identical. Okay, the above equations are identical, that means same. Okay, so we take any one equation, that is 2x1 minus x2 which is equal to 0, then 2x1 which is equal to x2, and take the coefficients x1 x2 then 2 1. Okay, so therefore the corresponding eigenvectors is, that is x2 which is equal to 1 comma 2. Okay, and this problem, the eigenvalues are minus 3 comma 2. The eigenvectors are, that is capital 1, that is minus 2 comma 1, and x2 that is 1 comma